All right, so topic 4 for inference on the AP exam. The biggest thing is just deciding the method a lot of times. And just to decide the method, I go through in my class these 4 questions, okay? So, for example, I say, well, how many samples are there? Is there 1 sample or 2 sample? So when you're writing your method, you always start out that way. So for example, if it was a 1 sample, on the method, you would say 1 sample, okay? Always think of that first. How many samples do I have? So what you have to do is you have to decide, is it a Z or is it a T? And I'm not sure if Hans uses this acronym, and I think I've talked about it before, but I have taught my kids, it's in our AP book, ZAP and TAX. Okay, and how do I, what does that mean? Well, the word ZAP, hold on here, has a P in it, right? And so if you are dealing with proportions, you are going to be dealing with the Z interval or the Z test, okay? If you're dealing with a sample mean, an X bar, you're dealing with a T interval or a T test. So for example, if I had something that was dealing with proportions and it was 1 sample, I would say a 1 sample Z, okay? And then I have to decide, is it going to be an interval or a test? And the side note for the interval is an interval will always say construct a 95% interval, or it will say construct a 90% interval. It will always have that word construct. Now, another side note for that part with the interval that you might want to put as just like a little laundry list on the interval, watch out, does it actually say construct and interpret? Because if it just says construct, okay, so let me make a little arrow here. If it just says construct, it's only looking for a lower bound and an upper bound, okay? It's not looking for the statement. If it says interpret the interval, that's where you say I am 95% confident. That yep, no, it's okay. The lower bound and the upper bound. Do you want? Oh, is that what Mr. James calls it? In the max. Okay, I call it the lower bound, upper bound. It doesn't matter. Okay, so if it just says construct, you can stop there. And the reason I say that is because some interpret the interval. So I can give you a more specific example if you want. Let's say we were constructing a 95% confidence interval for the average weight of a rabbit, okay? Do you guys have any idea the average weight of a rabbit? Let's go with 3.5 in between both of you, okay? All right, so let's say X bar for a group of 20 rabbits, right, is 3.5 pounds, okay? And then I want a 95% confidence interval, right? And now let's say I have a sample size of 10. So now, am I dealing with a T interval here or a Z interval? A T interval because I have the X bar. So I take that X bar, I have 3.5, right? Plus or minus, oops, P star now, right? Z star, the critical value, times the standard error. So that's how I get my upper bound and lower bound. Is that what Mr. Jans calls the min and the max? Okay. If it says interpret, then we would say, I am 95% confident that the interval from blank to blank contains the true, this is so behind, the true average weight of a rabbit. I think it's going to pop up. I just typed it all. There we go. So I'm 95% confident that the interval from blank to blank contains the true average weight of a rabbit. Okay, then the interval. I guarantee either on the multiple choice or on the free response about interpreting the level. How do you guys feel about interpreting the level? Yeah. So that would be, let's say I'm like working for someone. I'm saying, okay, this is the data I found. I'm 95% confident the truth is from here to here. And your boss says to you, what do you mean 95% confident? Like the 95% piece, interpreting that. Do you want me to go through that? That's okay. So then that means we should go. What 95% means is if we would do that, if I can get back to it. Here we go. Just want you to see it. All right. And it's so delayed. Okay, well, I'll talk about it while we wait. What 95% means is if we would do this interval over and over again. So what I did with my class is I did heads, and I did this actually with my Intro to Stats course. So let's say you flip a coin 20 times. 8 of those heads, will it land 8 for you if you did it 20 times? It could 9, it could be 10. Is 8 unreasonable? No, but we use that X bar to build our interval, right? Because if I come up here and I write it down, I say, hey, my confidence interval. Oh, I'm so frustrated. I'm sorry. I had the most problems with my words in this. Come on, okay, we'll just go over here. Lord. Oh, okay. My interval, right? Whether it's an X bar or a P, no matter what, it's your statistic plus or minus your critical value times your standard error. Okay, so if Jackie gets 8 out of 20 and Sam, you get 11 out of 20, both your intervals are different, your upper bound and your lower bound, right? Because you're building it off of this statistic. You're taking this and you're adding your margin of error to it, and you're taking the other statistic, right? So you're taking 8 out of 20 and you're adding the margin of error. This is the margin of error. And then you're taking this statistic and you're subtracting that. Both of you are going to get a lower bound and upper bound. If I would repeat this process 100 times, I'm going to get a bunch of different lower bounds and upper bounds. Because what we should walk away with statistics knowing is there's variation in statistics, right? So I 10 out of 20, the next 100 intervals, 95 of my intervals will have the truth. And what should we know about the truth? 50% should be in there, no matter what. I could get an interval from 49 to 52. Even though 49 is really close to 50, I could get one from 49.999 to 52. And the truth is still in there. If I repeat this process 100 times and build 100 intervals, it will contain the truth. Okay, and that's what 95% confidence means. Does that make sense?
Yeah, I get that.
Okay. Questions? All right, let's go back. If I can ever get back. Okay, so we were talking about where were we on our, ask ourselves, is it 1 sample or 2 sample when we're deciding the method? Next we ask what? If it's T or Z, right? Interval or test, and I was saying that with an interval, it will say construct an interval. And then a test, it will say, usually the keyword will be, is there sufficient evidence? So if you want to write that down, that's kind of your key to know if there's a test or not. Is there sufficient evidence? Okay. And then finally, I'm so frustrated. Finally, you say, okay, then for what? So here, right here, if I underlined it, these are all parameters, okay? P would be for 1 sample. P1 minus P2 would be for 2 samples, right? So P is for 1 sample. P1 minus P2 is for 2 samples, dealing with proportions. Mu is for 1 sample. Mu1 minus Mu2 is for 2 samples. And then match is it with difference. So most likely, if you get it in a free response problem, it will be something where the treatment is what? Do you remember the match pairs? Where you're given both treatments. So it would be like a before minus after. Okay?
Oh, like,
and you're looking at the difference.
So it's like if someone like took a test and took another test and they compared it.
Exactly, but you have to be taking the 2 tests. So let's say, okay, so Sam, here with the difference. Let's play pretend. if I have two AP classes and I want to look at the difference in average test scores, that would be this. There's two samples.
Yeah.
But if I have one sample where I just have my AP class and I say, I'm going to be taking an AP practice exam on the iPad, and then I'm going to have you take it by hand. And I look at the difference of those, because now my one class got both treatments. I subtracted. And so this is a one sample t-test pairs, like the test on the iPad, and then the same test again on paper. Question? Okay, and then the last one is the slope. The last thing we did, slope theta. All right, and then the other things that we have would be our goodness of fit, independence, and homogeneity. And I'll talk all about that here in a second. So let's quick go through our conditions. And if you leave, just leave. And I'll finish this video no matter what. Okay, so you can go online and get that. I would pause it and restart my computer. It'd be frustrating watching it too. You know what I mean? Like, it's frustrating for you, but for someone,
Was there any audio in the video?
there is audio in the video, so they're hearing this all now. I could edit it, I guess. You know, like just this extra. Okay, so here I have a Z interval versus a test. Okay, so one sample versus two, there's not much that's different. RIN, okay, so for a Z interval or test, no matter what, the conditions are the same. What does R stand for? Do you remember that one? Yep, random. So you either state that it's random in the problem, so I would say random stated, or most likely we'll say SRS stated. Remember, a coin flip is random, rolling the dice is random, putting names in a hat is random. So any of those kind of things are ways to be random. If it doesn't state random, you can assume randomness. We can assume that they use some kind of random way to put them in the groups. I can say, well, what if, what if, what if? If they just ask you to discuss conditions, then you could be suspicious that a condition is wrong, okay? It just say, write down the conditions, explain them, but don't perform. That's the only case that I've seen on a free response question where the conditions don't work. Usually if they ask if there's sufficient evidence, the conditions should all be okay. And if they're not okay, then maybe proceed with caution, okay? I've only really seen the conditions be wrong if they discuss the conditions and explain them. And don't do the test. Questions there? Okay, what does I stand for? And what is the independence rule? Yep, so it's the 10 times little n is less than capital N. And I always have my kids write it out. So I'm like, if the sample size 30, I'd say 10 times 30 is less than all students, whatever that population is. Okay, and then what does N stand for? Here, this is the big one that people get mixed up on. Do you remember? The N? It's normal, yes. It is normal, but you're two different normal ones. That's okay. So you go back to Zach's. Okay, it's P's. So Z is the first. So you're going to be doing the N times P has to be greater than or equal to 10. And the N times 1 minus P has to be greater than. Catch when it comes to a confidence interval. A confidence interval does not give you a P. Remember, a P is your assumed truth, okay? A confidence interval will only give you a P hat, so for N, okay?
Wait, what is the difference between the P and the P?
Yep, nope, that's okay. So, for example, in a significance test, one example I actually do with my class, it's a thing that Harvard did. And I'll just, okay. It's a study that Harvard did, and Harvard found this thing that said 40% of all college drinkers or college students are binge drinkers.